Hey everyone! Welcome back to the channel. I hope you're enjoying our C# journey so far. In the last video, we took a deep dive into delegates and events, which allow you to build flexible and event-driven programs. Today, we're going to focus on another essential concept that will help make your code more efficient and reusable: generics. Generics are one of the most powerful features in C#. They allow you to define classes, methods, and interfaces in a way that can work with any data type while maintaining type safety. This means you can create more flexible and reusable code without sacrificing the safety and efficiency of strongly typed code. In this video, we'll cover what generics are and why they matter, how to use generic classes and methods, the advantages of using generics over traditional methods, practical examples to help you understand generics in action, common pitfalls to avoid when using generics. So, grab a drink, get comfortable, and let's dive into the exciting world of generics in C#. Let's start with the basics. What are generics? Generics allow you to write code that works with different types of data, without specifying the exact data type when you write the code. Instead, you define the type when you use the code. For example, imagine you need to create a method that can return the larger of two numbers. You could write separate methods for int, double, and float. But wouldn't it be better if you could write one method that works for all data types? That's where generics come in. Here's a simple example to show you how this works. In this example, we define a generic class myGenericClass T. The T indicates that T is a placeholder for any data type. When we create instances of this class, we specify the type, int, string, etc., that we want to use. This allows the same class to work with different data types, making it flexible and reusable. So, why should you use generics? There are several key reasons. 1. Reusability. With generics, you can write a class or method once and use it with different types. This saves time and reduces duplication. 2. Type safety. Generics allow you to catch type-related errors at compile time, rather than at runtime. This helps you write safer code. 3. Performance. Generics eliminate the need for boxing and unboxing, which can improve performance, especially when working with value types. Let's take an example to show why this is important. Without generics, you might write a method like this. The problem here is that the object type can store any value, but you lose type safety. You need to cast the value back to its original type when retrieving it. If you cast incorrectly, you'll get a runtime error. This approach is also less efficient because boxing and unboxing occurs when working with value types. With generics, you can avoid these issues entirely. Now, let's talk about generic methods. You don't need to create an entire class as generic, you can make individual methods generic as well. Here's an example of a generic method that compares two values and returns the larger one. Explanation. The method getMaxT is a generic method that works with any type T. We restrict T to types that implement IComparable T using the where clause. This ensures that the compareTo method is available for comparison. We use the method to find the maximum of 2 integers and 2 doubles. The same method works for both types, making the code more reusable and type-safe. One of the most common uses of generics in C# is with generic collections. The .NET framework provides several generic collection types, such as list T, dictionary T-key, T-value, and stack T. These collections are much more efficient and safer than their non-generic counterparts. Let's take the list T class as an example. Here's how it works. In this case, list int is a list that can only contain integers. If you try to add a string, the compiler will give you an error. This is a huge advantage over non-generic collections, where you'd have to check the type manually. Sometimes, you want to restrict the types that can be used with your generic classes or methods. In C#, you can apply constraints to generics to limit the types that can be used. We saw an example earlier with IComparable T, but here are a few more common constraints. 1. Where T, struct, T must be a value type. 2. Where T, class, T must be a reference type. 3. Where T, new, T must have a parameterless constructor. Let's look at an example that uses multiple constraints. In this example, T is restricted to reference types, class, that have a parameterless constructor, new, ensuring that T can be instantiated with new T. Before we wrap up, I want to highlight a few common pitfalls to avoid when working with generics. 1. Overcomplicating your code. While generics are powerful, don't overuse them. Only make a class or method generic when it genuinely improves reusability and type safety. 2. Not using constraints. If your generic method requires certain behaviors, like comparisons, don't forget to add constraints to enforce them. 3. Boxing and unboxing. Avoid mixing generics with non-generic types like object, as this can lead to performance issues due to boxing and unboxing. By keeping these pitfalls in mind, you'll be able to make the most out of generics without introducing unnecessary complexity. It's challenge time. Let's put your knowledge of generics to the test. Challenge: create a simple stack data structure using generics. Your stack should be able to 1. Push elements of any type onto the stack. 2. Pop elements off the stack. 3. Check if the stack is empty before popping elements. Bonus challenge: add a method to peek at the top element without removing it. Implement a method to clear the stack. And there you have it. Today we've covered the powerful concept of generics in C#, learning how to make our code more reusable, flexible, and type-safe. We explored what generics are and why they are important, how to use generic classes and methods, how to apply constraints to limit the types used with generics, common pitfalls to avoid when using generics. Generics are a core feature of C# that make your code more efficient and safer. By mastering generics, you'll be able to write more scalable, maintainable, and reusable applications. In the next video, we'll dive even deeper into more advanced topics in C# programming. If you found this video helpful, don't forget to give it a thumbs up, subscribe to the channel, and hit the notification bell so you never miss an update. Thanks for watching, and I'll see you in the next video.